A film student wishes to determine if the average running times of films produced by two motion picture companies, Paramount and Universal, are different. A sample of 5 Paramount films gives a mean of 97.4 with a standard deviation of 8.87. A sample of 7 Universal films gives a mean of 110 with a standard deviation of 20.32. We want to determine whether the average running times are different for the two companies at a level of 5% and what conditions must hold for our test to be valid. So we want to test for our two population means, the difference in population means, and when we do so, we always use a null hypothesis that the difference is equal to 0, which is equivalent to, if you want to write it this way, as saying mu1 is equal to mu2. For the alternative, we need to choose one of 3 signs, greater than, less than, or not equal to, and that's determined by what we wanted to find out in this problem. And what we're asked is if the running times are different. So we're going to use a not equal to sign here. So we're going to do a two-tailed test. Now our test statistic is a t. What we do is take the difference in our sample means. Sample mean for group 1 is 97.4. For group 2 it's 110. So that's our x bar 1 minus x bar 2. We divide by s squared over n for group 1. So our s is 8.87. We square that and divide by our sample size of 5. That's our n1. Plus 20.32, our standard deviation for group 2, squared over our sample size of 7. And what we'll get for our test statistic is negative 1.458. We'll need to look up our p-value in our t-table, where we use degrees of freedom of n1 plus n2 minus 2. So we'll get 5 plus 7 minus 2, giving us degrees of freedom of 10. When we go look up our t, we just look up the positive, so we'll look for 1.458 in row 10 of our t-table. Here's row 10, and we're looking for 1.458, so we're going to find it's between 1.372 and 1.812, and those correspond to tail areas of 0.1 and 0.05. So our tail area is going to be bounded between those two values, 0.05 and 0.1. So we can bound our p-value between here, paying attention to the fact that we are doing a two-tailed test since we have a not equal to. So we want the area in both tails beyond our test statistic, meaning we want to double those bounds. So we're going to get a p-value between 0.1 and 0.2. Comparing that to a significance level of alpha 0.05, we see our p-value is bigger than our alpha, in which case we are going to fail to reject the null. So we will say here that we do not have significant evidence of the alternative, and the alternative is saying that there is a difference. We do not have evidence of this difference. So we do not have significant evidence that the population mean running times differ for the two film companies. Lastly, what we would need to mention here for our test to actually be valid is that we need a normal distribution for the running times for both of the film companies. Our sample sizes are 5 and 7, which are both small samples, so we need normality here for both the running times for the Paramount films and for the running times of the Universal films.